In 1996, this gray slab of plastic, the Toshiba Satellite Pro 405CS, was the best-selling portable computer in the world. This was an era when consumer computing was finding its footing in pop culture, and Microsoft recently rolled out Windows 95 to fanfare. This chart compares the 16 megabytes of RAM and 75 megahertz processor inside this laptop directly against the baseline requirements of a modern computer. Today, you can pick one of these up used for about $250, but by any modern metric, it is entirely obsolete. It represents the absolute peak of a specific computing era, one that existed right before the tech industry agreed on universal standards for digital connectivity. Which brings us to a specific challenge: taking a modern, computationally heavy 3D voxel game and attempting to run it on this 28-year-old architecture. Today, we expect software to be seamless. You click a button, a file downloads, and the application opens. But in 1996, the digital ecosystem was entirely fragmented. So before we can even test the raw processing power of the Toshiba silicon, we have to cross a massive 30-year translation barrier just to get the hardware and software to communicate. The first hurdle is getting the game files onto the hard drive. We can't simply connect Windows 95 to the internet, because the operating system does not support modern web security protocols. We also can't use a standard physical workaround, like a thumb drive, because this laptop was manufactured before the USB port was widely implemented. The natural next step is to try an adapter, but wiring a modern Mac directly into a 28-year-old serial port using a serial to USB converter simply doesn't work. This animation shows exactly why that adapter fails. A vintage serial connection relies on a strict linear stream of data. A modern USB connection routes data in discrete packets. Hardware from different decades physically speaks different languages. Without a shared software translator built into the OS, they cannot pass data to each other. With direct transfer off the table, the only reliable way to get data onto the 1996 machine is to burn it onto optical media. This creates a tedious logistical chain. You have to order specific micro USB cables off the internet just to connect an external CD writer to a modern laptop, purely to write a single file onto a plastic disk. To move a few megabytes of invisible code onto a retro machine, you have to build a manual, physical supply chain that relies on mail carriers and moving mechanical parts. But getting the game onto the hard drive is only half the battle. Once the file is there, the vintage operating system inherently rejects the modern program's architecture. This flowchart illustrates the problem. Programs rely on dynamic link libraries, or DLLs, modular instruction manuals Windows requires to execute functions. If a connected piece is missing, the program halts. Here, the system stops because it is missing OpenGL DLL, required to render 3D graphics. Because the vintage laptop has no internet access, discovering each missing or incompatible file initiates a punishing cycle. Every single missing dependency means burning a brand new physical CD to test a fix. Even when the game technically opens, the visuals are corrupted. Fixing that requires manually tracking down and installing Aero-specific texture files. It's an exhausting hunt for files that highlights the invisible luxury of modern package managers, the systems working behind the scenes to automatically fetch and update dependencies without us ever noticing. Eventually, with every missing file correctly mapped and loaded onto the disk, the application finally launches. The resulting gameplay experience is completely unplayable. The environment manages to render at exactly 1 frame per second. Compared to the fluid, high frame rate standard we expect from games today, this feels less like a digital world and more like an incredibly sluggish screensaver. We successfully hacked the communication barrier, but the raw processing bottleneck of 1996 silicon is an absolute physical limit. A 75 MHz processor can only draw so many polygons at once. Successfully forcing two completely isolated eras of technology to cooperate proves that even a 30-year gap in standards can be bridged with enough manual effort. The fact that a game from 2011 completely overwhelms the best-selling portable computer of 1996 is a real-world demonstration of Moore's Law in action. Processing power compounded rapidly, leaving old hardware in the dust. Running a modern application on vintage hardware requires an immense amount of manual labor. It forces us to recognize the invisible, standardized digital infrastructure, from USB protocols to automated software libraries, that we rely on every day to make modern technology feel like magic.